of computers, we are looking at data-enabled process improvement, data-enabled problem solving, or so-called data-enabled decision making. I'm not going to touch base on the business processes, marketing, finance, all those things are part of it. Essentially, process improvement and problem solving. Those are the key things which you, from an improvement standpoint, every organization will be looking at. So I'll break the myth now. So I'll take the worm out now. What are we talking about? Statistical data analysis, analytics, data science, ML, AI. Look at, these are not the latest jargons. It's been there from 1950s, 60s. Okay. So if you talk about, if you go, I'm crediting the slide to David Mantrop from Statistically Speaking. He's a professor from Germany. He gave a talk where artificial intelligence, machine learning, deep learning, everything was there from since my birth, before my birth also. But they were part of operation research or decision sciences. So if you look at the deep learning, so you put the data and answers, and you apply machine learning algorithms, and then you will get rules. That's part of machine learning. And you take those rules and bridge with the data, and you'll get the answers, so that you are transferring some of the decision making capabilities to some of the systems, or else so-called programs, or so-called the machines. So that's how can you, from a leadership standpoint, from a management standpoint, how can you empower your resources, in this case machines and programs or the algorithms, to solve problems on your behalf? Essentially, that's how artificial intelligence I could define. So you are empowering decision making, just like in human resources, we call it, how can you empower your subordinates to take decisions, something like that. How can you empower your machines or your algorithms, or else your systems, to make a better decision? And essentially, you are the ultimate decision maker, but you are empowering your machine. So that's how artificial intelligence. So I know we started with the CI, so-called customer intelligence. We moved on to BI, business intelligence. Now we have moved on to AI, artificial intelligence. So we moved from C to B, B to I. So even though it's reverse, actually we are in the progression. So while all this, we call it as data to discovery. So I'm going to talk about discovery, the world. Discovery and analysis are two different words. I keep telling discovery a lot of times. Given the same data set to two people in an organization, or else in your department, only if I give you two data sets, a same data set to two different people, they might analyze in a different way. Essentially, discovery is more from moving from one place to another place, but also it includes learning and also understanding the ecosystems around you when you move from one place to another place. So discovery is identifying the patterns, identifying some of the insights from the data. So you have the data, and then you discover something, and then you deploy it. So analytics or problem solving, any kind of your statistical applications will help you in solving two things. One is solve a problem, or else identify an opportunity. Essentially, you will be using analytics to do only two of these. Either you solve a problem, or else you identify an opportunity. Okay. So if you look at the data, hey, some people are buying spectacles with speakers. Bose has come up with this. They have spectacles with speakers, and you start analyzing who are the people. You start identifying an opportunity there. Hey, people are buying this. So in this market, it's gaining momentum. So let's get into the market. So you identified an opportunity, and then you discovered some problem. So Toyota found out, or else Suzuki found out some issue with their braking system. So through process discovery, they started doing a lot of testing, or else design of experiments they identified. So you either identify a problem and solve it, or else identify an opportunity and capitalize on it. So it's a cycle. So any problem should be viewed as an opportunity to capitalize. So you have a data, you have a discovery, and deployment is very important. So all these things needs a sound leadership. And I just want to differentiate between engineering and a little bit of leadership as well at this point of time. You being managers, I want to highlight, you might do a fantastic discovery, but you should ensure that the leadership around it, or else you should orchestrate all those phases, the data discovery and deployment, so that the end customer should get benefited. We call it as usable AI. How much AI can be used or consumed? Okay, you might create a lot of use cases internally, but how many of those can be used in real life scenario, or else how much of it can benefit customer is very important if you're looking at any of the AI projects or else any of the statistical discovery. Just to give data, keep asking the question, you prepare data, you explore, you model the data, you implement, you act upon it, and then you evaluate that. And that's how the 3D approach. So we call it as 3D approach: data to discovery, and then you have to deploy. So data becomes the integral component. At the same time, leadership is very critical because you have to orchestrate all these phases. You might be working with multiple departments: data department, analytics department, front end sales people, or else from a manufacturing setup, shop floor people. So end of the day, someone is going to consume your analytics output, right? Analytical output, and then ensure that you see the light in the tunnel. So you might do a fantastic analysis, you keep it to yourself, fantastic. It doesn't make any sense to anybody, but it should be helping someone at the end of the day. It should contribute to the knowledge, or else it should contribute to the deployment, or else a consumption. We call it as C to C. And sorry, that means you have a concept and then you have a consumer, or else how do you convert that into cash? Okay, C to C, concept to cash, we call it as in analytics space. Okay, so real world research happens. Just to give you a simple, you start, you ask whether it's a problem or an opportunity. I said any research or else analytical activity should ask, is that a problem or else an opportunity? Just because someone wants to do it, probably we should not be doing it. In real sense, somebody wants to do analytics project and you ask me, hey, is there a problem? No, then why are we doing this? Okay, so first, if somebody gives, it goes back to the famous statement, right? If somebody gives me 10 years to construct a bridge, probably I spend 9 years to plan about it and think about it, and then I take the last 1 year to execute it, because it's very important. You spend a lot of time in due diligence and understand, hey, who is it for, how it will be used, how much of time. And I see a lot of AI cases, probably I feel some of them are missing this particular element. They might do a simple algorithm and then extra like a fantastic model, but end of the day, who is it's going for and how it will be used, how much time. Very, very important is whenever we talk about decision making principles, there is something called theory of bounded rationality. You give me some data, just like your tablets, right? Even information has expiry date. It's very important. Even information has expiry date. You give me some information which is already expired, which I cannot use it in a, it might be a fantastic insight, but it is already expired. I don't want to use it, or else it's at this point of time I cannot use it. So it doesn't make any sense. The value is lost. Okay. So how it will be used, how much time I do have, when they want it, all those questions need to be asked. The art of questioning is very critical. And then you ask the next question, hey, data is available or not? And once you think data is available, is data dirty? You ask the question. If not available, go and collect the data, or else there are some service providers which can help you to get the data. You buy the data. And then if data is dirty, clean the data, and then you start statistical data discovery, or also called statistical data analysis. Last but not the least, where many of the people where I've seen failing is telling story. It's not about communicating happy value or else your AICBSE, which model works better, here your test is better than control or control is better than validation. That is not the question. That is being your data scientist role. But can you tell a story? End of the day, storytelling, how are you communicating to the end stakeholders in a way they understand? If I'm going talking to a finance person, probably I should use the language of finance. Hey, if you implement this model, you want to save this much cost. If I'm talking to a HR person, hey, if you want to use this attrition model, your average attrition will decrease. Average attrition, whatever, per 100 employees, 1,000 employees, whatever, per percentage. If I'm talking to a production person, hey, if you use this algorithm, your average yield will increase by 2%. They're not looking at your AIC, BAC, whether you used XGBoost or a logistic regression. They'll be least bothered. And this is what I'm trying to say. It's very important that you tell the story, at the same time use the language they would like to listen, at the same time they would like to understand, and they know how to understand it also. So you being a data scientist or an AI person, you might do a lot of data analysis, you might do a lot of algorithm. End of the day, how do you put that across? How it's going to help the customers? How it is going to help the organization? How it's going to create the value? Accordingly, you have to build a story. It's very important that you cover the entire start to storytelling. Everything is very critical for any of the AI person or else the analytics person. Okay, so machine learning in engineering management, I'm not going to talk. I think professor would have taught all this. I think be it supervised learning, unsupervised learning, classification, regression, clustering. Why I'm showing this, all this are part of JUMP, and including the XGBoost algorithm, which is our most of the Kaggle competition. I know people explore XGBoost. Okay. One more important thing is, so we are all not born statisticians. Okay, so we all come from engineering background or BSc background, BCom background, or BA background, whatever it is. But it's very important that we should start thinking like a statistician. You may not be a statistician, but you should start thinking like, very important. I put a, it's called Yoda approach for me. This is what you and your objective, your data, your hypothesis, your assumption, and your analysis is very critical to derive meaningful insights from your data. You should start thinking like an analytician, statistician. Very, very important. You may not know the mathematics behind it. You may not be knowing about it, but you start understanding and then start think like a person who can interpret statistical output. That becomes very critical in problem solving. Keep that in mind. Okay, so we want to talk discovery process. That's what a little bit of introduction to AI and statistical discovery. While everything for me is part of statistics. Okay, so statistical discovery, on you onboard the data, okay, and then you clean the data and you visualize the data, you analyze the data. In analysis phase, univariate analysis, but that means you start analyzing the data one variable at a time, try to understand the data, and then you start analyzing two variables at a time. That means bivariate analysis, just to see any correlations or causations in that. And then you start looking at multivariate analysis. That means you start combining interaction effects. There could be multiple variables, could be linear interactions, non-linear interactions, or quadratic interactions. And then you get into the optimization and simulation. In analytics world, they might call it as descriptive statistics, inferential statistics, or as in analytics, they call it as prescriptive analytics, predictive analytics, and as well as descriptive analytics. I'm coming from the topmost to bottom one: descriptive, predictive, and prescriptive. That becomes optimization and simulation, little more of recommendation engine. So essentially, you're going through this phase. You have the data and you have a problem at hand. You start discovering an answer, so-called from a statistic standpoint. Okay, so you might put a different wordings for it, but this is essentially you start looking at onboarding the data, clean the data, visualize the data, analyze the data, optimize your solutions, or else find out the optimal factor settings, you call it as. I'm going to showcase a couple of them. Okay, so I wish I had enough time to take through all this data onboarding and cleaning, cleansing, multiple formats of data, volume, variety, velocity, veracity. How do you treat outliers, messy data, missing data? How do you work on visualization? How can you create? According to me, most of the problems can be identified and to an extent solved if you know how to put a proper visualization. I'm going to show some visualization. And you start looking at descriptive analytics and then getting into the little more on the predictive multivariate bit of machine learning algorithms. And then quality and process. I know I want to touch base on a little bit of manufacturing also. I know most of you will work for service industry, but some of you might work for manufacturing industry as well. While we call it a service Six Sigma, is also process Six Sigma, or process mining is also an important thing which I would like to show you. And then one of the unsung hero of analytics called design of experiments. How do you find the optimal factor settings? How do you manufacture a best pizza in the world, or how do you cook a best coffee or a dish, and how do you make best wine, how do you make best laptop? That's called design of experiments. Okay, there could be multiple combinations. What would be the best factor settings which can solve your multiple responses or its multiple objectives? So that's where the design of experiments comes into the picture. So all these things are kind of statistical discovery techniques where you can apply each of them based on your data and based on your objective and goal. Okay, so when I said goal, what is your goal? When you have the data, what your AI or data analysis or analytics should do. The first thing is look at the right quadrant. Okay, either you want to explain or describe something, use analytics. Explain a relationship in terms of underlying factors that affect the response. For example, if you're into real estate, I'll take a real estate example to start with. How much does an extra bedroom increase as a house price? So you're trying to describe or explain. So if I increase one bedroom, if you're working for Shobha Properties or else Mantri, what is that extra sensitivity of one extra bedroom on price? How much our customers are ready to pay? That's a model. That's an explanation, your description. Accordingly, you're going to make your pricing decisions. Next is cluster or segment. Examine relationship with no intent responses. I'm not looking at any of the response here, but I want to find the groups of people whose purchasing behavior are similar, or groups of houses that have similar features. Okay, I want to find out those things. If you get into Magic Bricks or whatever it is, website or No Broker, what are the groups of houses in and around Dan and Sagar which are similar in nature, and how can I segment them, cluster them? Why I'm going to cluster or segment them? Probably I might want to personalize it based on the similarities and dissimilarities. That's your goal. Could be one of the goal is to cluster or segment. It's very important that clustering or segment, because when you look at the finance perspective, how do you cluster high taxpayers, low taxpayers, no taxpayers? How do you segment them? How do you classify them? AI should come there, right? So obviously, as we speak, Government of India uses some of the governments in state governments do use SAS and other algorithms to classify, identify who could be a potential person who may not pay tax, even though he might be a high net worth individual. So they identify the segment in the cluster that they work on that algorithm. Next is prediction. Use existing data to predict future outcomes or the response in new situations. Predict the home prices on the basis of characteristics of the house and location. I say I'll give you number of beds, number of bathrooms, and what is the square feet, and I'll give you the locality also, and then you predict me the price, and you tell me what is the price. So that's, you start predicting. Second part is one of the example which we worked as a I know one of them, my colleague who is working, is called CAT modeling. Okay, CAT modeling is a short acronym for catastrophic modeling. There are a lot of modeling techniques. Catastrophic modeling is how do you predict that there could be a hurricane in California next month? Very, very important. You know, if you look at the overall history of hurricanes, there could be 10, 15 hurricanes, 10 hurricanes in last 15 years or 20 years. The number of so-called number of observations, okay, number of observations will be very less, and the number of variables would be huge. What are the characteristics which define hurricane? At the same time, how do you predict there could be a hurricane? Or else, how do you predict an earthquake? How do you predict? What will be the probability that there could be an earthquake in so and so place by this month? Because that is an important element for insurance people to define the price of premium, right? How do you define the price of premium? So there's something called insurance. Swiss Re is one company. where all these insurance companies go and then insure their insurance back. It's called reinsurance. Okay, Swiss Re, that's a company which. So how do they predict the price? How do they predict that there could be a natural calamity? It's not like your Amazon. Okay, this guy has bought some product, he will buy another product. You have a lot of data so that you can do, but there could be some examples where you may not have sufficient data. That's where you use some of the bootstrapping or else penalized regressions, and then some of the Bayesian algorithms to predict. Another example is, what is your goal? Identify or screen. Find the important predictors or features reduce the number of predictors, or else which of the many characteristics of a house and its location are important to whether the house will receive an offer or not. So what are the key variables which can increase the probability of an offer? If I'm sending a credit card to you as a banker, what are the key things? There could be many things in a credit card, right? How much credit, your capability, your credit history. There may be a lot of variables. So what are those 3-4 variables which can increase the propensity or else probability that you would accept the credit card? So identify a screen. If somebody is manufacturing a chip, okay, from an electronic standpoint, Apple chips or Intel chip, but the chips which are used in phones and all, they have lot of processes, okay, thousands and thousands of processes. So how do you optimize and screen them so as to find out the key important processes so that they can focus? It's called trivial many, vital few. So how do you identify? So what is your goal? Your AI should, or else your statistical journey should focus on these goals. You could have multiple goals also. It's fine. You want to explain at the same time, you want to identify. Absolutely fine. Or you have to iteration. You have to do a lot of iterations between them. For example, I showed you reducing predictors and then fitting an explanatory model. Absolutely fine. So define your goal is very important. What is the objective in any of your statistical journey? Okay. So I'm just talking about some of the techniques aligned to those. If you're looking at segment, you might use clustering, segmentation methods, or multivariate methods. If you want to explain a fitted model, use standard least squares, ANOVAs, regressions, ANCOVAs, logistic regression, generalized regression. Okay. You want to identify screen, use predictor screening, use bootstrap forest, generalized stepwise selection, fit model. Want to predict, you can apply any of your supervised or unsupervised machine learning algorithms like random forest, neural network, can include explanatory models, particularly generic as well. Okay, so you have to be very clear on what is your objective as well on these cases. Accordingly, you might want to apply. So these are all algorithms. While these were there, if you ask me, yeah, these were there 20 years back also. It is also there. It's just that the computing power of computers have enabled us to perform quickly. And that's where the word data science or AI, all these things are coming up. Your data formats are also becoming different now that we have audio data, video data, sensor-based data. So that your machine is capable of churning huge amounts of data and then make solutions for you, or else take decisions on your behalf. So that's the same thing I wanted to say. Okay, so we'll take an example enough of PowerPoint. So I'm going to get back to, so detecting and addressing common data hygiene problems. I'll get back to you. Before, I assume that you can see my screen and then you can hear me properly, right?
Yes, Murali, we can hear
Yes,
you.
sir.
Thank you so much. So I will go to, so this is how jump looks like. Okay, I've been pronouncing it as jump, jump, jump. So you might say, hey, why he's calling us jump. It is JMP, so it is pronounced as jump. Okay, that's how it is. If you look at, so this gives you a simple Excel based, this sits in your local desktop. And then as we speak, you can go ahead and download, there is a 30-day free trial available. So what I'm going to do is I'm going to take, so I wanted to take some of the data examples here. So there is a sample data here. I want to show a journey here. There are a lot of sample data available. Close to 600 plus data sets are inside JUMP, which are classified based on the example. Okay. So, but I would like to show you something real. Let's take an example. Go to Google. How many of you know this? There is something called redfin.com. Okay. So Redfin is a real estate. Now we spoke about home. There's a lot of pressure on me to buy a home in Bangalore. Okay, so I've been staying here close to 20 years. So my family, especially my wife, thinks that it's very difficult to buy a home in Bangalore. Now I decided I cannot buy a home in Bangalore. Let me check in Minneapolis. Okay. So what I'll do is I will go on. This is like your magicbricks.com, right? So I'll go and want to search what are the homes available in Minneapolis. This is called redfin.com. It gives you the price, how much of beds are available, how many bathrooms are there, and then it gives you a price. Take it from me, it's it's cheaper to buy home in US, Minneapolis, than to Bangalore here. Okay. So expensive, damn expensive in Bangalore to buy a home here. Apartment in US, you can see this. You can easily buy these kind of with the kind of equal EMIs and the low interest rate. Okay. So this gives you the detailed data of all these things. So I can go ahead and then onboard the data, like I can open any kind of data set. For example, if you see that even the Excel files, Jump, SAS data sets, I can connect to Teradata warehouses. Even the PDF files I can import through Jump. If you have a PDF files, I'll show you that also. Let me show you a PDF file, okay? So I have a PDF file here, population data. So I can import the PDF file data. So which page I'm trying to import. So it gives me, hey, this is what it is. You can see this. I want to import only this page. It gives me this. So I can go ahead and import. But I want to scrape the data directly from internet. This is what I'm trying to show. I want this data. I will take this Redfin data. Okay. I will say, select the link, copy the link, and then I'll come to Jump and I'll ask Jump, hey, go and then get me the data file, internet open. I can connect to data warehouse, but I want to internet open web page, and I'll say copy the link, and I'll say it goes to the internet and then gets me the data. Okay, so just like it is listed, whether it's sold or not. No, it is not sold. Property type, so it gives little more information. Address and then city. Okay, so why I chose Minneapolis, that's the place where I lived for a couple of years, so that's the reason. So I knew this place little more. And then and it gives you the price, the same data which was part of the internet, right? So price, number of beds, number of bath, how many bathrooms are there, location. Very important location is, some of them are suburbs, some of them are remote area, some of them are city. There are a lot of things. Square feet is how much is the built up area, and then lot size is overall. You might have a car parking, you might have a pathway, you might have a lawn, so that includes the lot size. And then how many years since it was built, so year built. Days on market is since how many days it is there. Square feet, dollar per square feet. HOA per month is House Owners Association. This kind of a maintenance, if you're in an apartment, you have to pay a fixed month maintenance fee per month, right? That is also there. And status, whether active or pre-on market. All this information is here. Okay. So now that it also gives you longitude and latitude. So because I want to geographically do something, I can create a lot many graphs here. This is simple data. Now my goal is to find out what are the factors which affects the price of a house. What are the key factors which affects the price of my house? Or if I'm trying to buy, what are the important predictors which define the price of house? First thing is, the best part is, you see here, the Jump understands what is a categorical variable, what is a continuous variable. I didn't say anything to Jump. Jump scanned it and then it understood, hey, price is a continuous variable, bed is a continuous, bath. Location is not a continuous numeric variable. It's a location, status, all those things. By the way, you can change it also, right click and then change whether your data type is character or nominal, whatever it is. But more or less, Jump understood what the data is looking like, and then it understands. So if you want to create a little more graph, okay, I want to see where is the price and all. So now there comes the first thing is, from a data discovery standpoint, I want to see, is there any outliers? Are there any missing values, right? So there is a header graph. I'll see. It gives me, looks like, okay, Minneapolis city. Looks like there are a lot of things which are based out of Minneapolis. These are all like areas, right? Rajajinagar, Vijayanagar, so something like this is. And then it's all state and then zip code. Price looks like it varies from 3.7 million to 32K. So this is the highest price. The bet says there is a 12 bedroom. Okay, I don't know who uses 12 bedroom. So and then bathrooms, 7 bathrooms, 7 to 1, and majority you can see these are all dynamically interlinked. So I'm just checking the data set here, how it looks like. The first thing which I do is I'll screen the data. Okay. First thing is I want to see missing values. It's very important that you check for missing values in the beginning. I'll say I'll explore missing values, and I'll say I'll put all these variables. Is there any missing? Okay. And let me see all this price, bed. These are all the things. Let me select all these things. Is there any missing? Okay. So now jump as a missing value report. Okay, so it gives me a missing value report. Hey, when it comes to price column, there are no missing values. Beds, yeah, there are 6 rows where there are bed is missing, bath is missing, square feet is missing, obviously. Lot size 53 is missing, year built is missing. So some of the, I can see that what is the missing value. And I can also see a little bit of clustering here from a visual stand. You can see this. Okay, so all these red colors are, you can see, yeah, look at this, lot size, bed size, these are all some values are missing here. And then I'll go with the missing value snapshot, bit of little more at a row level. And then it's up to me what I want to do with. I want to do multi-normal imputation. So once you have missing value, you impute the value, or let's go ahead. It's up to the researchers you want to do, or as the analyst, whether you want to classically impute by based on mean, median, mode imputation, or else little more regression based imputations like multivariate or multivariate SVD imputation, automated data imputation. It's up to you what you want to do. So I'll say, let's keep it. You want to impute multivariate, it'll ask me shrinkage is recommended or not. So you go ahead and then impute the values. So now that I imputed, automatically the values have been imputed. Now that if you run, there won't be any values of, it depends on what is that imputation method, whether you don't really need imputation or not. It's up to individual. Once you impute, you look out for a little more on the miss outliers. You always treat the outliers, right? You can see that zip code price. I want to see, is there any outlier here? Let me take all those continuous variables for outlier treatment. It gives you quantile range outliers, robust fit outliers, multivariate robust outliers, or whichever it is. You want to see that, hey, these are all the outliers based on your quantile range. Okay. So, or else if you want to see robust fit outliers, or else you want to see a little more on the multivariate k nearest outliers based on, so you can also see these are all outliers. And what you want to do it? No, it's up to the individual. You want to convert them as missing values, or else you want to impute, cut off them, take out, exclude. It's up to you individual. Depends on your goal. Very important, because there's no standard method how to treat missing values or else outliers. It all depends on your goal and objective. While there are methods to deal with, but at the end of the day, you being an analytic person has to take care of how do you going to treat the missing values or outlier treatment. There is a question I could see. Sir, Chetan says, okay, if there are any missing values in predictor variables, should we impute the data or drop such missing values? How does same work with multivariate analysis? It depends. Okay, there is no straightforward answer. Impute, essentially, you should first draw a distribution, how much of them is missing. Okay. If missing is majority, then if you drop that variable, it doesn't make, if you drop those observation, it doesn't make any sense. If you impute, what will be the impact on the model? You should be knowing it. How do you interpret also? If you don't impute, what will be the impact? That's where we call it, called context comes into the picture. You being a researcher, this is the difference between a machine and you, right? So you being a you should think about what will be the repercussions or impact on your future decision making if you impute, or else if you just omit those records. So the decision yours. If you're looking at a medical terms, the risk is more. Okay, if you impute. You cannot assume. But if you're looking at a leather technology, a small food drug manufacturing company, imputation is fine. How much risk also is involved with case to case makes a lot of difference. You got my point, right? So should we impute the data? Yeah, it depends on which area you're working at. If you're working a low risk area or a business, it's okay to impute. But if you're working in a high risk, I would not recommend it. Depends on what is the final decision making, what will be the effect or impact on your final decision. Risk return trade-off will always be there. I hope I answered your question, Chetan. Any web page, right? Yeah, Sumant asked, yeah, the data can be collected from any web page as long as your web page allows the data to be scraped. Okay, or else you have to write a small script to scrape the web data. And the data should be in HTML format, and the website should allow you to scrape the data. You got my point, right? And you cannot go to Government of India and then scrape the data. The Government of India website should also allow you to scrape the data. Okay. So if you have any questions, please let me know. So this is how you start exploring the outliers. We didn't do anything with the outliers. There is a capability. Now that you want to do a little bit of visualization of the data. Okay, so I can also do a little bit of something which I like is patterns, explore patterns. This is all exploring screening data, response screening, process screening, predictor screening. I'm not going to show all this. I want to see explore patterns also. Is there any patterns in this? But I don't see that coming up here. Okay, if I see anything, I'll put all these things. Okay, only the continuous variables. So if there is any patterns also, if there is a minimum cross column duplication run. Okay, so I can see this, how many are on the patterns. So this will be helpful if you're collecting a data in a primary research. Most of the market research methods, you go and collect the data, and then there could be a probability that some people can manipulate the data. You can identify using pattern exploration. At the same time, I'll show another example here. Let me minimize this. This will be a good example for you to understand the patterns. I have this data visualization and patterns, explore patterns. There you go. So here is a data from a water treatment. Okay, so water treatment where you have a lot of sensors data, right? Sensor measurements. You'll get the water, domestic water. Before that, it has to check for the quality of the data. If your sensor is sending the data, and these are all the sensor data. Okay, so these are all the data for different measurements. You can see this. There are 128, 39 columns. The sensors are sending for different pH, all these things. Now that if you want to find out, to check the quality of the data, I want to explore the patterns here, and I'll say, okay, and I'll make it 10 here. You can see this univariate summaries here. You can see that there are few things which are continuously kind of following a specific pattern. Okay, so minimum cross duplication run is 10. I will take it as 2. Okay, so I can see this. Look at this. This particular, if I want to highlight this, highlight the row, conditional highlighting. Let me highlight the rows. Okay, order columns, duplicate across column, fraction length. If you look at the data set here, you can see how many of these have been highlighted here. And then you can see the patterns. There is some problem with respect to some of the data being in a patternized manner. That means your sensors are a little bit of failing in between so that they're malfunctioning, or else there is some issue with the sensor. You can start looking out for patterns in these kind of areas. So there are a lot of capabilities that are available here where you can start exploring that. You can see the 23612. 12 times it is repeated. That means consistently. That means there is a problem with kind of, you can highlight it, longest runs, fractional, format widths, duplicate, ordering columns. So you can save columns, save data table, duplicate sequences. So you can see this. These are all this duplicate sequence data where there is some problem. And then you can see, you can start understanding the quality of the data. Here is an example I just showed you. There are a lot many examples available in JMP. So missing values, outliers, getting data onto JMP, and then transformations. Probably you would have learned about it. Lot many data may not fit your distributions. You check for the some of the assumptions of your regressions, and then if required, you go and then transform the data, and then we'll come to the cancel. Let me get back to our housing, right? Visualization. Okay, so now that we have this house data, I want to visualize and go and then graph builder. And there are a lot of, if you go to the graph, there are a lot of conventional graph like surface plot, scatter plot 3D, cell plot, all these things are here. But I want statistical discovery. I want to understand how my data looks like visually. So I may not go on mute on my video so that you can see the full screen of visualization. So if I want to see price, I'll just take and drag and drop the price here. Look at this. It gives me a scatter plot matrix. I want to see box plot. Look at this. These are all outliers. There is a house whose price is more than 3.5 million. So if I take the average, okay, somebody has a question. Sir, for feature engineering, is there is any way we can introduce new column perform manually? Yeah, you can always include that. For example, I'll show that after this. You can transform, or you can you can take log of it. All those things can be part of it. Okay, Sumant is asking, is there a feature engineering easy way to do that? Okay, so here is visualization. Okay, there is something I saw. Hey, here is a problem. There is a data set which is here. I want to see histogram. I can see the histogram here. Okay, you can see this. If I want to increase the box width, I can always do that. You can see this. Okay, so here is a histogram. Yeah, I want to see based on, let me get back to this. And then I want to see based on number of bets. Okay, I will drag and drop here bets. What is happening with, I want to see histogram here, how it looks like. And it's a bath. I want to wrap it, start over. I want to see, is there any direct relationship with the price and as well as bets. Okay, I just want to drag and drop it here. Okay, you can see this. Hey, initially the number of bets increases. Okay, the price increases, actually number of bets. After some time, the bets remain constant, the price increases. Essentially, that means there could be something beyond bets. It's not about if you have 12 bets, the price will be more. No, after 6 bets, hardly anything matters from a price standpoint. They're not interactive. There is no causal relationship, but there is a causal relationship in the beginning stages. You can see this. Now that I've with the same thing, let me check with the bathrooms. Okay, so I will add another. Looks like bathroom, the more people prefer. Okay, so there is a higher price with respect to higher number of bathrooms. I'm just creating this graph, okay, visually. And then I want to see with respect to square feet. I just drag and drop here another variable. Hey, there is a direct relationship. Now I'm getting into the statistical discovery mode. I said that, any technology should help us to perform quicker and then enable us to do discoveries. I'm started doing discovery here. And then let me put a lot size. That's nothing but your super built up area in our, okay, so there's hardly anything. Looks like something relationship, or else I want to see, let me see with respect to status. With respect to status, I want to see on the market, pre-on market, how many of them active. And if I want to see a line graph, I can see a pure line graph. If I want to see a contour map, I can see a contour map here. If I want to see a violin kind of a chart, this is kind of a violin chart. And if I want to see a heat map, I can do a heat map. If you want to export, edit, copy graph, or else you want to export this graph, export into an image, PDF, HTML, interactive HTML, Microsoft Word, PowerPoint, whatever you want. You can export. I can also add a little more on the local data filter. I just want to show. I want to see based on so-called days on market. Okay, so I can add another filter here. If I want to see only this. Okay, I want to see which are recently on the market, how many days. You can see this. I can play around this with and then make a little more. analysis are, so I want to see only which are available in last 1 month. Okay. This gives you only 1 month with respect to bit of heat map also you can create. Or else you want a area map, you can create a area map out of it. So the choice is yours. You want a regression, you want a regression, you can fit a regression directly here visually. Okay. So looks like you can see this 95% confidence level. I'll take put the status here back. So it's up to you how you want to visualize the data. Just an example here. Similarly, I can show another example I have for visualization. Let me close this. Data visualization, airline delays. Okay, so these are all the airlines which came, which arrived, and I just want to create a little more on the visualization, analyze. I'll go to graph builder, and I want to see which airline came, had a delayed arrival, which came early. Okay, so I also want to put days of the month here, and then month onto the x-axis, and then arrival delay to the color. Okay, and I'll say heat map. So done. So I can see this in the month of December, especially in the late December, there are a lot of delays. Okay, so you can see the red color is delay. The minus is so-called minus bias came early. Okay, so I can see that in the June there were a lot of delays. So you can create a heat map, and then you can just go ahead and then add a little more local data filter, so-called let me check from the airline perspective. Okay, so whether it's American Airlines, yeah, they did have delay. Delta, Northwest doesn't do a lot of delays, looks like. So now if I'm choosing a airline as a customer, rather I look at Northwest, especially in the December month, they didn't have a lot of delays. But Northwest is a very small airline within US. If you're looking outside, yeah, US Airways also had little delays. And in fact, they had a lot of early arrival, Southwest. So it looks like American Airlines has little more delays than, yeah, Delta had a lot of delays. Okay, so they are the big airlines. Okay, they connect all other continents also. So something like this, you can start exploring the data. The best part is you can copy paste the data using JMP. If you have an Excel file, the best part is you can explore data analysis from, I'll take, for example, Excel import. If you're looking at this, there is a JMP add-in. You can do lot many analysis from here only, fit Y by X, fit a model. So if you're used to Excel, you can use this also. Okay, let me close this. So just looking at the clock, we're still in the visualization. I'll just move on. Okay, so our goal is to find out so-called the price. Let's get back to this. Okay, we'll close this. Excuse me, I'll stop at this point of time. Any questions? So somebody asked me feature engineering. So if I'm looking at price, if I want to create another feature, I'll right click here and I'll say new formula column. You want to transform them into round, log, whatever it is, aggregate them, distribute them. This is univariate transformation, the way you want. If you want to combine these and then make another variable, go ahead and then right click, new formula, combine all those variables, right click, everything is. So essentially from last 32 years, the pain of each researcher and a data scientist have been addressed, because you might take a little more time to write a code to understand all these things and then do this. But with this, you can easily do this. Right click work. So now that I'm looking at after visualization, I can also do a little more on the graph builder. I want to show this. So if you see this state, I can put this as part of graph, and then this is geospatial as well. I can edit graph, and then background map. You can connect to NASA server or a simple Earth or a street map surveys, and then you can also do geospatial analysis using JMP. So this is how integrated. And now if I'm looking at property type here, if I drag and drop, and it will show you all those analysis, and then I can cluster visually also. Visually, I can, using graphical methods, I can cluster which is closer to a sea or also a lake, which is closer to a highway, and then I can do that. I can cluster them and then create a new variable so that I can use it using them in the model. So those are all part of it. Okay, so you Let me get back to this. So now that I'll go and then do a bit of distribution here, and I'll put all this, let me put all this variables, location is not required. Okay. So now once I do a little more distribution, you can see this, it gives you, okay, let me stack it into, you can make it horizontal, vertical, okay, and make it vertical only, arrange into rows of 4. So now that you can see, here it is. So this is zip or postal code. It doesn't make any sense. I'll take out this. Price is very important for us. So all these things are, this gives you a histogram. If you're looking at, okay, so if you're looking at year built, what are the prices of the properties in 2020 or else after 2000? If you select this, look at this. These are not so expensive. It is in the medium. Everything is dynamically interlinked in chunk. This way, it gives you a little more discoveries. Okay. If you look at the price of 1.5 million, hardly the distribution where it is. It's 1920s. Probably looks like vintage or else too new. Higher price properties. Square foot, if you go higher on the square feet, you can see this, the price is always high. You can do. Lot size, this is more of, it has given kind of distribution here. You can increase and then make it access settings. You can change it, whatever you want, right? Like, so just gives you a little more distribution. And then square feet for price, how it distributed. If you're looking at mean, median mode, go ahead and then do display options and then say, I'm looking at summary statistics, mean, median mode. You can customize little more on skewness, variance, kurtosis, whatever you're trying to calculate. So jump understands what that you're exactly looking at next, and it gives you. One of the things which you will also learn is whether price is normally distributed or not before you go ahead and then do it. So put a normal quantile plot. Do you think it is normally distributed here? Definitely not. Okay, so I'll just try to fit a normal distribution here. Look like it is not normally distributed. The same thing, the goodness of it, or Shapiro, Well, Converse, and Darling test. It also saying that hey, it is not normally distributed. I want to fit a best distribution. Let's see. I want to see which is the discrete, if it is a discrete variable or it's a continuous. Let me fit all. Let's see which is the best fit. Let me ask jump to fit all the distribution here. So looks like Johnson Su is one of the, let's see how it goes. So it's going to take a couple of seconds. Very important that you understand the distribution of each of the variables before you go ahead and then do analysis. Okay, so yeah, looks like, okay, it's calculating each of the distribution p-values for it, and then it gives you the best distribution so that you can apply the distribution if you're doing a little more regression modeling, especially in the generalized generic. So you can see it's log normal, how all this distribution, you can start fitting it here and then see what is the exact distribution. Looks like Johnson Su is the best distribution which can fit based on the AIC and BIC, not normal distribution. Just I'm giving you a little more. And if you're statistically exploring this, you can also do a little bit of profilers here. But if you're looking at non-parametric test, you want to test of pain, all those things are part of it. If you're looking at a process capability from a Six Sigma, whether there, so you can do it. Now that this is how you start doing univariate analysis. You can also do a little bit of bivariate. I want to analyze price with respect to other variables. I'll put a price here. And let's say I want to analyze with respect to bed and bath. And then based on the lot size, I want to year built. Okay, there could be a chi-square test. So don't worry, jump understands. Okay, it's fine. This is fit y by x. No variables, some required variables are not specified. I'll take out the variable built. Oh, the price should be there, right? Price I should add here. Sorry, that's my Y response. Let me take this also, days on market also. Yeah. So now it understands, this gives you a bivariate fit, price by bets. Okay, you want to fit a line. So it looks like there is a direct correlation. So this is a simple regression equation price. I'm looking at two variables at a time. With respect to bath, I want to fit a line. I can fit a polynomial. Looks like line doesn't fit here. Yeah, but the mean, let's see how it goes. And yeah, or else fit lot size, or else bivariate fit. This is a market. So you start exploring bivariate, two variables at a time. You'll get some statistical understanding of how data looks like. And then follow with the multivariate analysis. You want to do a multivariate methods, you can reduce the number of variables using all your principal components, discriminant. I would like to do a clustering. Let's see. I want to cluster variables here. I'll do a hierarchical clusters based on the price. Okay. And all these variables. Let me see. I think. So you want to do a multivariate analysis. Okay. This is how. And I'll make how many clusters. I want to make it 3 clusters, 4 clusters, and then let me color the clusters here. This is a cluster history, and I want to show a little bit of constellation plot. So you can see there are some clusters here. If you look at the 6 clusters, I made it, how many clusters? I made it 3 clusters, right? You can increase this, you can play around, and let's see what are the cluster variables also. Number of clusters, I want to see parallel concord plot. Okay. So are there any groups of people or as groups of houses which I can cluster because so that I can customize? Looks like the price, bets, look at lot size is one thing. There is on the dollar per square feet is one variable which can distinguish between 2 clusters, and there's here one cluster which is little high on days on market. If I take out the variables, I think I'll make a little more meaningful observation. Let me take out that variable. Edit. Redo analysis. Okay. So, sorry. I will take out that, and then I want to see only 3 clusters. I'll take out that variable. This is what I'm showing a little bit of multivariate analysis. Cluster analysis, hierarchical clusters. Price should be fine. Lot size, square feet. Okay. This all continuous variable I'll take. So now I'll make, okay, automatically concord matrix comes. I'll make it only 3 clusters if I want to customize. Okay, and then I'll say, okay, so just to make it looks like, yeah, meaningful. There are some low price, okay, and then number of bets is low, number of bats is low, square feet is low, but a little bit of low on the low lot size and a little bit medium on the maintenance charges. But this clusters looks like different from this and this from this. So you start clustering them. And the important thing is we want to do a little more regression. I'm looking at the clock now. So analyze, I can apply any kind of predictive modeling. Okay. Neural network, partition, all these things, and put a simple model. Okay. What is my Y variable is price. Before that, I would like to do a bit of validation also. Okay, analyze, predictive modeling, and I'll create a validation column. I'll split the data set into, I don't have a stratification. I'll split the data into 75 and 25 and say go. Okay, so now it has created a validation column randomly. You can see this. If you want to see the distribution, you can see 25% is 87 rows and 263 rows. So you can visually observe that one also. Analyze, and then I fit a model, and I'll put price here as Y variable, bets and baths, okay, and then square feet here, lot size, and then year built. Year built may not be, I'll remove, that's not a continuous variable. Yeah, let's see these 5 variables. I would have included the area location also, but I have to explicitly mention which is closer to city, which is, I would have done a little more geo analysis before coming to this phase. Yeah. So I just fit a regression model. So square feet looks like maintenance is important, look like, okay. And the number of beds, baths, and lot size. I thought it's the other way. Actually, my data has thrown me in a different, yeah, we can always fine tune this model. So this is how, and there's something, all the statistical understanding you have, all these things. The best part about JMP is even if you don't know anything, you just take a question mark and drop it here, and it'll take to the internet, and then it helps you how to interpret that. Okay, so that's the best part about JMP. You not be knowing all the statistical terminologies here. So the one thing which I want to show is all this row diagnostics, your Durbin Watts and all those things are here. I want to show profiler here. Okay, this is a very powerful thing in understanding statistically. Okay, so let me make it a little small here. If I'm explaining this right, okay, let me put this way. So your bets has an inverse relationship. Okay, look at this. Your price decreases. No, yeah. So higher the number of bets, and then you can see this. You can easily understand what will be the impact if you increase the number of bets. Your price is coming down. Okay. That means there is some problem with the data. Also, we need to check that out. Okay. Number of bats. Yeah, I understand that has a direct relationship. Okay, this is where statistical discovery comes into the picture. I can visually see square feet. Yeah, I can see this. What is happening with the square feet? I'll take what this variables looks like. Okay, so I'll take out these, remove. Okay, I'll take only these two variables. Simple. I'll make a simple model. I'll take a complicated model in my next example. Okay. So if I increase the square feet, you can see the price also increases. Maintenance also has a simple two predictors and one response variable. So this is how you go ahead and explore visually also using a prediction profiler. So if you want to extrapolate, you can go ahead and then extrapolate what will be the price if I go beyond square feet also. If you want to simulate, you can simulate the data. Okay. You want to change the distribution of each of these variables, and it will be very much useful for a process discovery in a manufacturing setup. You can extrapolate the data and you can forecast also. Likewise, any other algorithms or regression, you can save the columns or the predicted formulas and then go ahead and compare, or else forecast for the future references. You look out for the outliers, Cook's distance, all those standard statistical measures are part of JMP. Okay, so this is, I just took small example to showcase. Okay, I would have taken, instead of mean price, I can build a model based on median price also. Okay, that's one of the example. Take another example here. We'll do a little bit on a process discovery. Okay, so here is an example. Okay, so now I'll shift gears from little more from a real estate to tablet manufacturing. Okay, so statistical discovery now, the need of the hour is COVID medicine, right? So everybody's looking at the COVID medicine. So I'll just explain you how a tablet is manufactured. Okay, so you have raw material, active pharmaceutical ingredient, they call it as API, and then you milling, and then you blend it with others, and then you compress into tablets, and you coat it for shelf life, for taste. For kids, you have to give little more sugar on top of it. So you coating, and then you check some critical quality parameters. One of the critical quality parameters is called dissolution. That means how quickly it dissolves in water. That's a dissolution. So it has, the more quickly it dissolves, better it is. So at least a 70% of the tablet should get dissolved if you put inside the water for 2 hours. That's a basic expectation for this example, right? So that's a dissolution. Always companies want to have a higher dissolution. That's an important thing, how quickly it dissolves in whatever format of the deck. So we'll do a little bit of data to discovery. The question is, what are the parameters which affects the dissolution? The company wants to increase the dissolution of the tablet. Company wants to understand which are the parameters. They want to visually understand, and they want to do a little bit of model building, and they want to do a little bit of optimization. They want to find out what are the optimal factor settings so that which can increase the dissolution. So they want to run a little more prescriptive analytics also. And then Monte Carlo simulation will do a little bit of design space, and I'll show this example. Okay, so you might hear many examples in the banking area and retail area. Okay, you go to Google, you find many things, but I wanted to showcase a little bit on the manufacturing setup also, because analytics, you call it as industry 5.0, internet of things, artificial intelligence, most of the things are getting applied in the manufacturing setup also. And that's the reason I thought of taking it. I would have taken a banking credit card example, but I thought of taking a tablet production because now the need of the hour is science and pharmaceutics. Okay. Here's the data set for you. That is the data visualization. Tablet production. Okay. So dissolution, you can see this: screen size, mill size, spray rate, coating viscosity, compressor, lactose. Just imagine that you're manufacturing and there's a blend speed, coating, temperature, atomizer, whether the product is accepted or not, that is acceptance or rejectance, and then bit of dissolution values are here. So this is a simple data set. Okay, so if I want to see graphically, I will do a data to discovery. Meanwhile, I see a question here. Sorry to see this. This software seems to be very easy and interesting compared to Tableau, but what is the frequency of using software in companies? Hey, great question. Now that I'll stop myself, if you go to jmp.com, okay, this is a SaaS company, okay, SaaS product. If you look at this jump in action, customer success stories, just to let you know, Tata's use jump, okay, which are the companies use jump, there you go. By company, I can vouch that there are a lot of top 100. If you take top 10 companies in the globe, I know 50% of them use JMP software. Jump, BASF, McDonald's. You can see all these are customer success stories. It's being used. Pharmaceutical companies like AstraZeneca, Oxford, McDonald's. You can see this. It's used across industries. P&G uses it. Saint-Gobain. Okay, you can see this. Somebody asked me this question, so I just sort of sharing this with you. Which are the industries which uses it? Chemistry, conservation, consumer, education, government, healthcare, life sciences. All this industry uses it. And what are the application areas? So this is publicly available information. Okay. Did I answer the question, Chetan?
Yes, sir. Yes, yes. Thank you,
Thank you
sir.
so much. So you can see the lot of case studies. This is a big product globally. Even if you look at the research gate, even the researchers and scientists extensively use it. And if you ask me which are the colleges which are using it, I'll just show you. If I'm sorry, how we help this is students. If you look at which are the colleges which are using it, okay, how do I get jump? Okay, these are all the colleges in United States. Okay, I can scroll down, scroll down, scroll down, scroll down. Close to 600 plus universities across the globe use jump. Okay. Harvard, TAMUS, UCLA's, India. If you look at India, it's some of the SP Jains or Indian School of Business, ISB. So they all use jump for teaching and research. Just some of the universities here. Yeah. So publicly available information. So let's get back to our tablet production. So if I want to visually explore the data, graph builder, and I want to see dissolution, just drag and drop. Okay, I want to see histogram. You play around with this. And then I want to see by screen size. Go ahead and now that what is happening, low screen size 5, if you see this, screen size 5 has a lower dissolution compared to screen size 3. I made some insights. This is called discovery. So I've not made the complete solution yet, but I'm still finding out some reasons. Hey, okay, start over, and I'll say dissolution. Is there any reason where mill time is directly related? Looks like mill time has a direct relationship with the screen size. Let me add blend time. Looks like spray rate, coating viscosity. I want to see by screen size here. I want to see by overlaying screen size here. You build your own graph. That's how it's called graph builder. While you can use the conventional graphing techniques like go to graph, all these things are here. There's something called award-winning graph builder. You build your own graph. Let's start over. I want to see heat map. Go ahead and then drag and drop it. Jump understands what you're looking at. Simple heat map. Quickly you can build. Or you want to see, as I say, regression. And I'll see simple like dissolution, or if you want to see a 3D scatter plot matrix. Graphing, scatter plot 3D, I want to see how it looks like. I can go ahead and then build a three-dimensional scatter plot matrix. So essentially, the way it is built is any technology should help you to perform faster and quicker. If the technology is a bottleneck for you, then we have chosen a wrong technology. And discovery doesn't stop from data onboarding and just visualization. It should give you till end of your decision making, should tell you what should be the optimal factors, how should I go about next. So I'll show you that in this example. So now that you did a lot of visualization here, uh, and I want to see a little bit of univariate analysis. I want to see distribution, I said, right? I just put everything here on the distribution, and then it shows me all the frequency histogram. I'll stack it into, arrange into rows of 6. I want to show something. Now that I want to see lower dissolution, right? That is my problem. If I select the lower dissolution, you see automatically screen size 5 has got highlighted, mill time low has, that means lower dissolution is related to lower mill time, screen size 5 and higher spray rate. I'm making all this. If you take any sales data, right, in retail, your lower sales is related to just like visualization only I can start doing. This is called interactive dynamic visualization, where both data set and as well as your graphs are integrated. Okay. So now I do this. And if I want to check normality, I'll go and then put a normal quantile plot. I'll check, put a normal quantile plot. Okay. This gives you normal quantile plot, more or less normally distributed, but I want to check fit normal. P-value says, hey, normally distributed, but you want to play around with that, right? You can also do little more on the t-test, univariate. I want to test of mean. I want to do 74, whether it's 74 is statistically significant. Okay, I'm statistically discovering it. Looks like it is statistically significant. But if you want to understand better, this is the best part about JMP. Okay, if you're a student or a teacher, hey, what if I start moving, changing the hypothesized mean value? Look at I can visually understand and learn better, right? Hey, if you want to discover, what if my sample size decreases by 50%? Look at the impact on my p-value. What if it is a low tail test? What is a high tail test, right side test? If you're doing inference, power of a test is an important. What is the power to discriminate between your population, okay, and the sample? What if you start moving towards population? Look at this, the power decreases to distinguish. What if you start moving toward? What if you change the mean only, estimated mean? What if you change the alpha level? Instead of 0.05, you make it 0.25. Look at the rejection region. So interactively, you start discovering the data. Again, sample size. If you change the sample size to 50, look at what happened to your distribution. What will be the impact? So it is very important that you understand the implications also while you learn a lot many statistical techniques. This is very important that from the intuitive standpoint you understand. So, and you can also do if you are statistically discovering whether this process is able to meet our expectations. So I can also do a little bit of process capability. Okay, so I can see this little bit of PPK value you might learn in your Six Sigma concept, right? Now that we are looking at integration of Six Sigma, data science, and all those things, what is the CPK values? Again, very important is interactively, how can you understand? What if you change the lower specification limit? This is what you start understanding the impact of each of this. Lower specification, target. What if you change the mean? What if you change the overall sigma itself? Visually start understanding the impact is part of the statistical discovery. It's called Visual Six Sigma. There is a book by Mia Stephens. I recommend that to people. So this is how you start exploring. And if you want to understand a bit of t-test, a dissolution with respect to my screen size and compressor, I want to do, don't worry which one to do it. Just drop and drag and drop. JMP understands what to do. Now it has done a bit of one way ANOVA. Now that click here, you want to say pool t-test. Now you can see without looking at the p-value, you can see, hey, this 95% confidence level, the green color one, the rectangles, are so-called rhombus, right? Yeah, rhombus kind of quadrilateral. Okay, let me put this. So they are overlapping. So without looking at the p-value, I can say there is no statistical significance between compressor 1 and compressor 2 when it comes to dissolution. Visually understanding data is very, very important. So all this p-value will give the same thing, and you can go ahead and do a lot many things here. So this inverted red triangle, I always call it as curiosity button. It gives you non-parametric test you want to do, bit of equal, unequal variances, robust, normal quantile plot, all those things. Okay. So now that you start exploring bivariate, then comes the multivariate. Multivariate methods, just drag and drop everything. This is the best part. Okay, that's fine. So, okay. Now it gives you a bit of correlation matrix and a bit of ellipsoid 3D, what you can choose whichever variables, but I would be interested in color map on a correlation or scatter plot matrix. The best part is how my variables are interlinked. So I'll take out the points. I would like to fit a line here. Okay, I can fit a regression line directly here. I can fit little more on the ellipses, how my variables are looking at. And you can also see from a color map correlations, which are the variables are directly related. And you can also launch a principal component from here on the correlation. If you're reducing, go ahead and then you can reduce your variables. And you want to launch a factor analysis, confirmatory factor analysis, you can outlier analysis, all those things you can launch from here only, whichever. You can directly go and then start doing discovery. So now I understood there are some correlation between dissolution and mill rate. Some spray rate is negatively correlated. Some of them are positively correlated visually. Now that I've still not established that relationship from a regression standpoint. Now that I'll go back to regression, I want to build a predictive model. Okay, let's try to first make a validation column. Okay, I will say I'll split the data into 75 and 25, 20%. Now that it has done, let me put first which algorithm. I'll take analyze predictive modeling. Let me take partition algorithm. Okay, so what is my lot acceptance is my Y response. I want to understand screen says all these things, whether any of these variables. Okay, and there's a validation column. I'll put validation and then say I can choose which method: decision tree, bootstrap, forest, boosted tree, k nearest neighbors, neighbors. It's up to me. I can run all of this. So and I'll say, okay, so I can start splitting. Hey, it looks like spray rate is important. Next is within spray rate, mill time is important. I can apply any of these algorithms. Okay. So now I can apply this and then see all your so-called ROC curve, you got lift curve, you can see k-fold cross validation if you want to do within sample validation, how it looks like. So it's as simple as this one. Okay, and then you can save the formula, save the columns, predicted formula, whatever it is. Residuals are the publish the prediction formula, save prediction formula. I'll save it. Okay, so you can come back and see here is the most likely acceptance, the formula for deployment. For the same algorithm, I can fit a model, simple model. Okay, I consider Y as a, instead of a categorical variable, I take the Y dissolution, I'll put all these variables and I'll simply run a regression. Looks like screen size is an important. Look at this. Earlier, the other algorithm didn't give me a screen size. I think it was not the first variable. These are all the important variables from a P perspective, or else log worth, and these are all not so important. So the best part about my jumpers, I can take out this instead of now I'll just say remove. So it runs automatically adjust and then say these are all my variables. And then the important thing is prediction profiler. Okay, so I'm going to introduce another. So if you keep the screen size 3, if I increase the mill time, look at what is the impact on dissolution. Everything is positively correlated. And what is the impact on other variables? So this is called prediction profiler, which is very powerful in forecasting and understanding as well. It's very important that you understand also the phenomena. It's not only, see, most of the machine learning algorithms you apply to predict, or else you just want to understand. In science, especially in retailing world, I don't want to understand how consumers make a decision. I just want to predict whether they're going to buy it or not. That's more of a prediction algorithm. That's a black box if you're using any of your neural networks and all. That's all black box algorithm, but you cannot explain, understand better, but you can predict better, your prediction accuracy. But if you want to understand also, these kind of profilers would be helpful. Okay. So there was one question from Sumat Naik, how to download the output. Yeah, you need not download what you want to download the transform data and visualization. I showed you, right? You can go to jump, file, export. Export is whatever way you want, Word, Microsoft, PowerPoint, or else you can copy paste, copy table. Life is all about copy paste. Okay, copy paste works. Yeah, sir, does this software automatically analyze multicollinearity? Yeah, you, whatever you are looking at, Durbin, Watson test, your all those things are there. You have to check it. You have to do the residuals. Okay, so multicollinearity between, yeah, you, I think that's what you are asking. Yeah, autocorrelation, multicollinearity, all those regression diagnostics are here. Okay, row diagnostics are here, save columns, Cook's outlier analysis. If you're looking at so where's the column here, columns are here, looking at, so you're looking at whatever columns here. Okay, so all those variables, this is the standard error, right? Yeah. You will get log or p value. You start looking at actual versus predicted. Okay, residuals, all those things you have to do, regression diagnostics. I'm not going to get into the diagnostics. So this is how now. Okay, it doesn't stop here. So now I want to find out what is the optimal factor settings, how much I should keep blend time, how much mill time, how much spray rate, so as to maximize my dissolution. That is called optimization. Little bit of prescriptive analytics, right? So I can go ahead and then say desirability functions, and I'll ask jump to maximize my dissolution. So now jump runs an optimization algorithm and says, hey, keep the mill time 30, screen size 3, blend time of 17.61, spray rate of 388.40, coating viscosity of 110. You will get the maximum dissolution of 83% with a confidence band of 81 to 85. And you will be 99.6 desirability function. So this is called simulation and optimization as well, part of jump. And you can apply it to your marketing example. Hey, what should be my maximum sales? How to achieve maximum sales? What are the variables which are affecting my sales performance? I can take an example. Let me take a sales example from marketing perspective. Predictive modeling, statistics, descriptive. Okay. Where is the sales data? Where is the analgesic data, correlation, regression? Okay, here is my sales performance data. Okay, sales depends on your market potential, advertisement, market share, all these things. And analyze, fit a model, and sales is my Y variable. I'll put everything as my X variable. I can choose generalized, stepwise, whatever. Let me take stepwise regression, and then based on your minimum BIC, AIC criteria, P value, threshold, forward, backward, whatever it is. And I'll say go, and then it makes a model. All these variables are make a model, run, there you go. So now what I want to show is the profiler. Okay, so you can see this. Hey, if you change the market potential, what will be the impact on sales? Higher the market potential, higher the sales. Higher the advertisement, higher the sales. Higher the market share, higher the sales. So you want to optimize your sales, go and run an optimization. Okay, maximize desirability. So now jump says, have this value of 74065 market potential, advertisement cost of this, market share of this one, and you will get a maximum optimized sales of 80.8068. Okay, but it doesn't stop here, right? In sales or wherever, whichever functionality, for example, in this tablet production data, it doesn't stop here. Okay, we were in this analysis. You can also do a little bit of Monte Carlo simulation. This is where statistical, you're bootstrapping or else changing one of the variables. If I want to change the mill time to a different distributions, like I can change the distribution as uniform, and then I'll change this also as uniform. Okay, instead of normal, I take this as a normal distribution, and I'll make this jump has 20 different distributions which you can play around with. Okay, and then simulate. You can add a random noise to your data if you're doing an experiment, and then simulate the data and then start exploring this. So you can play with the virtual space of jump and explore the data set in spaces where you cannot do actual experiment, and then still run the regression, and then go ahead and then find out the optimal factor settings or optimal values for your yx variables. Okay, I'll stop at this point of time. Any questions? So I'm looking at 11:35 here. I can go on and go on. I can show a little bit of all sorts of structural equation models. If you're looking at multidimensional scaling, partial least square, all sorts of predictive modeling I can show. Let me apply neural network for the same data. Okay, I'll go and then dissolution is my y, and select this one. Lot number is not required. My mouse is giving me a hard time. So now that you can run a neural network also. Dissolution training, and this is what it is, validation data. I'll show one important thing feature in JUMP now, okay? So I'm going to open a JUMP 16, which is coming next year, okay? So JUMP 15 is what is the current version. I'll use the same data set, JUMP, sample data. You can see that the tutorials are inside JUMP, okay? And then statistics index, sample data. I will take the same tablet production data, okay, the same data. There is something called, so most of the times it so happen which algorithm to apply, okay, which model to use. There are a lot of modeling algorithms are available, right? Bootstrap, generalized regression, normal regression, partitions, all those things, okay? To analyze, predictive modeling, something called model screening, okay? While I will put my dissolution as my y response, mill time, screen size, blend times, force, coating viscosity, all those things as my x variable, okay? And I'll just say, okay. Now JUMP runs all the models. So look at this. The JUMP has run all the models like bootstrap forest, boosted tree dissolution, k nearest neighbor, neural networks, support vector machine, response distribution, stepwise, generalized regression, and it has given these, hey, you choose what you want. Now that R square along with the error, okay? So you choose, looks like boosted tree is a better model compared to support vector machine in this, looking at the R square. And the validation is also, from a validation perspective, neural boosted is a better model. This is called model screening. So end of the day, you write 100 lines of code or 200 lines of code to run all this, okay? If you want to run all these models on this data, you have to run at least so many lines of code. If you're using any other platform, in JUMP, just say JUMP, it runs all this, and then end of the day, I said, decision making is how quickly you can pass on the information closer to the decision maker. You might do a fantastic program, coding, visualization, but if you're sending the data or information after its expiry, or I call it as expiry date, it doesn't make any sense. So we talk about bounded rationality, how quickly you can give the information closer to the decision maker, valid, reliable information, so that he or she can take a better decision making. That's where analytics is playing a very important role, or artificial intelligence, you call it machine learning, data science, whatever it is. How quickly you can pass on the information closer to the decision maker. And the information has to be reliable, and then it should be effective in a timely manner. And JUMP saves you a lot of time in doing this, and easy to use at the same time, quickly it does. MBA is all about decision making. How do you make quicker decisions? And that's the reason organizations are using JUMP along with other softwares, especially from a SaaS perspective. So now you saw this. I would have ran all the models now. So this is more of a continuous, the y is a response variable, is a continuous variable. So it ran all those. But if I can run as a categorical variable, I can, then it will give you a little bit of other logistic regressions or all other regressions as well. So for this variable, these were all the models which I can use. You can also add, we do have XGBoost also. I just wanted to show XGBoost algorithm also. I can use XGBoost algorithm to run the regression, okay? So I stop at this point of time. Time series analysis. For time series, Chetan asked me time series analysis. So I'm looking at the clock. I wanted to wind it up by 12:30, if that's fine with you. And I can go on and go on. I haven't even discussed design of experiments, how it is used in data science. Okay. Okay, let me close this. Time series. Somebody wanted time series. I'll wait for a couple of seconds here. Chetan wanted to understand time series. Is there any other questions here? So in your go to analyze predictive modeling, multivariate methods, all these are your chemometric or multivariate methods, partial least square, generic, predictive modeling, including functional data explorer, time series is there something, quality, reliability, and the biggest thing is design of experiments. Okay, so I want to show that also. I'll wait for a couple of seconds. You want me to show time series? I'll show the time series. Let me take a breath. Any questions? I assume that no questions. Okay, so this is on the prediction side of it. Let me close this. I have a lot of examples here. So if you want to do fitness data, diabetes, sales performance, all sorts of machine learning algorithms. Okay, so mixed model, partial least square, bit of multivariate methods, clustering, factor analysis, discriminant analysis. Okay, so we'll take the time series data. Okay. So bit of somebody asked me time series data. Here's a monthly sales data. Okay, so this is the sales, and I've done a little bit of sales series, time series here, analyze, and I want to do a univariate time series. Okay, and then I can come here, specialized modeling, time series. This is my this. So essentially, you're looking for some of the basic assumptions. While you want to validate some of the assumptions of time series, whether it is augmented Dickey-Fuller. You can see this using augmented Dickey-Fuller test. So this is gives you mean, zero mean ADF, single mean ADF, trend, whether what kind of time series component is part of this data. So gives you autocorrelation. You can see this, and you can. I'm not going to get into the statistics behind this. So you can always do a ARIMA, seasonal ARIMA, or a smoothing model here. If you want to do an ARIMA, actually the seasonal ARIMA works better here. Looks like there's a seasonality. Seasonal ARIMA, want to say 1, 0, 1. I can check anything, right? And then I'll try to put 1 here. And then I'll say estimate. So now it runs. So you can see the seasonal ARIMA. You want to forecast for how many more months or whatever. You can see this AR101 moving average. So residuals, this is your forecast. What is from an optimistic perspective, what is from a pessimistic perspective, what is from a realistic perspective. Okay, this is your time series forecast, univariate time series. You can also do multivariate regression based forecasting also. Okay, so any other questions for me? Sir, a little bit about Six Sigma, Geeta Joshi. Thank you so much, Professor. This is Professor Geeta Joshi. Thank you so much for that question. So I'll come to Six Sigma. Okay. So if you look at JMP from analyze menu, there is something called quality air process. Okay. So we'll take control chart builder. There's a measurement system analysis, variability, process capability, control charts, and something called model driven control charts, Pareto, Six Sigma, or cause and effect diagram, Ishikawa, you call it as. All those things are here. Let me take an example of control charts. Okay, here's a process measurement, seven processes. You want to build a bar graph or X bar, whatever it is. Go to analyze, and then you want to check for quality and process, control chart builder, and you just drag and drop, you'll get the control chart along with all these things. Just as simple as putting. Okay. This is all drag and drop. And you want to do bit of process capability, which process is better. Analyze, go to quality and process capability, and take out all this process, put that, and then I'll say, okay, Ideally, you have to check for whether it is normally distributed or not. In this case, in jump, there's the best thing is you ask the jump to fit the best distribution. And then say, if you have a non-parametric option also, you can check and then say, click OK, you're doing process capability, you'll get a goal plot. If you're changing the PPK value, what will be the each of the process. And looks like for each of the process, it gives you start pouring around the process, it will give you individual chart of process. You can see which process also, you can see process summary report, process performance plot, and then summary reports are, I like this within Sigma. So you can see that stability index, yeah, anything above 1.0, 1.3 is not a stable process. Okay, looks like every process, yeah, 1.3 I would consider. So every process has a higher stability. In fact, it is color coded green, you can see this. And then from each of this, which are the processes, you will see capability box plot also. So stability index with respect to capability. So PPK, and then you can see which are all the process. There's nothing like capable but not unstable. There's no process. Look at this process and this process is capable as well as stable. This is where all your process wants to be centering. And this process is incapable but stable, and this is incapable and unstable. So probably we have to find out the reasons for this, analyze, and then start moving this process towards this. This is looking at, if you're looking at measurement system analysis, I feel these are all important from a data science perspective. And I think data science is all about solving problems, analytics. So people should get a lot of awareness towards cause and effect diagram. For example, if you're looking at Ishikawa diagram, how do you find out the root causes?
Yes.
So what makes?
Oh.
So what I'm showing is everything is part of jump. Okay. So we don't have a modules like structural equation model is a different module, or else this is a different module,
Yes.
quality, reliability, predictive modeling,
Yes.
quality, everything is part of jump and it sits in your local desktop. It doesn't require internet. Okay, so this is Six Sigma. I can go on and go on. So if you're looking at QSIM charts, so that's the best part about View Jump Starter. If you look at, these are all the capabilities. If you look at the quality and reliability, surface reliability, process, okay, these are all from a reliability standpoint. Control, these are all chart builders, QSIM multivariate control charts, operation curves, OC curves. Design of experiments have not even touched yet. Looks like may not touch today. Consumer research, all your uplift model, max diff model as part of your analytics. You can use this and then start exploring this, learn. I want to show a bit of, is somebody working on, any of you have explored structural equation models, SEM, I can show that, or functional data explorer for that matter. How do you put functional models using B-spline and P-spline? So I'm leaving last 45 minutes to you so that you can ask me question. Sir, can you kindly show, Sumukh says, text analytics using this software? Okay, so let's take a text analytics example. Where is text analytics? Mixed model, partial least square, time series, and text analytics. Text explorer. Let's take aircraft incidents. Okay, so this is a real data where you have the text, right? In the last minute, they put a narrative case, right? What is there in the black box, whatever it is. So there's a narrative. We want to do a text analytics of this narrative. What we can do is, I'll show on the jump 16. This will be a good one to show you. I can do a little bit of sentiment analysis also in this. Okay. So if you look at this analysis sample data, where is the text processing? Okay. So aircraft incidents, pet survey, text over big class families. I'll show you. Okay. So if I want to do, this is the same example. Go analyze, text explorer, and where is my final narrative? Okay. I'll put this as text columns. Okay, you can see the language, there are multiple languages are also supported. Cancel, okay. English, German, okay. Okay, the number of phrases, characteristics, you want a stemming, combining terms, tokenizing, what are the basic words or rejects, and I'll say, okay. So it gives me a term and phrase list. Okay, if you want to filter out any of the terms, and you can see, start looking at display options, bit of word cloud. I think probably you might be used to this. Let me make it color centered, and then coloring, better colors. You can see there's a lot of problems with the pilot. Okay, then comes the aeroplane. Ideally, we should have taken out this word. I can take it out. Okay, I recode, add as a stop word, make as a filter, whatever it is. All these options are here. You can do a little more beyond that also. It's called term selection, sentiment analysis. Okay, all these things are part of JUMP. So if you're looking at term selection, so what is that? Looking at fair weather, which are all the terms. If you're looking at, I know we did a case based on the patent data. So a lot of organizations do make a lot of submit for patents, right? So how can you analyze? I was working with another partner there. So how can you identify which are the companies focusing on the which type of patents? Somebody focusing on the chemical industry, somebody focusing on the electronics industry, somebody is focusing on the service industry. That's more of a term selection. Okay, and then you can also convert these data into numeric data, one zeros, and then do a little bit of latent semantic analysis, or else called document term metrics, right, DTM. And then you can incorporate that data into your modeling, predictive modeling also. Okay, so do sentiment analysis. It's going to take a little more time. Okay, that's how the time series you can do till ARIMA. If you want to do Arch and Gantt, you have to do a little bit of coding. But in sentiment analysis, you have to define which are the negative sentiment words and positive sentiment words. It does have a dictionary, but sometimes, it cannot take the sarcastic comments, we normally do it, right? So in those cases, it will be a little tricky. And then it's all subjective sometimes, you would have heard many examples in text analytics. Okay. So any other questions? We're nearing 12. Sir, if you could provide us the link to download JUMP software, try a student version, it will be helpful for the learn software. Okay, go to jump.com. That's the best part. www.jmp.com. No, not the earlier version. There is some jump.com. There is something called try jump. So you go to try jump, and then it'll ask you some basic information. You will get the jump. There is a fully functional 30-day free trial. You can explore this.
And sorry, Murali.
Sir.
You can tell them also regarding that Coursera course.
I'm coming there.
Yeah.
No, I'm coming there. I think I kept that here. You can see the statistical thinking. Yeah. So this is process discovery, and then I had something on the design of experiments. Probably I'll take another session, sir, DOE for analytics. Okay. So this becomes a little more chemistry. Okay. So there is where is the period fan? Okay. So there you go. So here is your sentiment analysis. Okay. Negative term, negation term, sentiment terms. Okay. All these things are here. Mechanical. So you have to code in some of these. There is another example also for sentiment analysis. Chips data. Do you have a sentiment analysis? Yeah. This is from basically your consumer, right? Wickedly good, too salty. Okay, terms and list. There you come, see your sentiment analysis. Okay, so good, perfect, best, or positive sentiments. Okay, so sentiment intensifier. So you can positive score, negative sum. Looks like overall it's a positive, good chips. Okay, so this is a chips data. You can see, and then you can see all the data set data here. This is on the sentiment data analysis. So JUMP is a highly powered software where you have a lot of options. The best part about JUMP is, I haven't shown you the best part about JUMP is the textbooks are inside JUMP. So some of the Doug Montgomery, if you're looking at applied statistics, elementary statistics, introduction to time series. So when you have something like this, you can have the data sets inside JUMP, you can learn. Okay, so, and then go ahead and do analysis. So the text, that's the reason this is extensively used for teaching also, saying other time. And then other thing is some of the teaching steps if you want to learn statistical thinking, right? So for example, I'll show you sampling distribution of mean. There are a lot of applets or so-called self-help, self-learning tools within JAM. Here is a population, okay? So I'll consider this as a rightly skewed population. So population mean, here is I'll take one sample, okay? I will take one sample and then find out the distribution. Looks like this, okay? I will take an other sample. Look at this. If I take the other sample, the mean is here, the distribution mean count, and the number of samples is 2, and the standard deviation of 2 samples is 2.86. Similarly, I can keep taking the samples. This is my positively skewed distribution. What if I take 500 samples and I want to see what my distribution looks like? Number of sample size, no, sample size is 25. Number of samples is 500 and I want to take, okay. I can do a simulation here actually. Even though my population is rightly skewed, you saw that my population rightly skewed, right? If I take randomly from that population and put a distribution of means, looks like it is normally distributed, right? Don't you think so? The population distribution of mean or sample distribution of means is normally distributed. This is how we can learn about central limit theorem. So even though your population distribution are unknown, if you take randomly and then put a distribution of sample means, that will be normally distributed. So what if I tell this in words, probably you take 2 minutes or a couple of more extra seconds to understand. But if I show you this visually, you will learn quickly central limit theorem. So something like this, there are a lot many things to understand statistically, learn the foundation, fundamental concepts of, example, there is something called, how do you teach yourself regression? Interactive teaching demonstrations like demonstration of regression, ANOVA, Bayes theorem. So a lot of applets have been built within that. And then don't worry about, there is something called jump/teach. If you don't understand, we do have a lot of how we work with faculty, academic students. Okay. So there are a lot of resources available. Go to YouTube, it is available. Teaching resources, how do I learn JUMP, all these things. So case studies are here, customer success stories have been part of JUMP, where they can use it to teach. You can see a lot of case studies are available, baggage climb or treatment facility, based on the kind of statistical methods you want to teach. Course material is there. We have written solution also. I'm lucky to say that I'm proud to say that I'm also collaborating with Professor Dr. Deepak in writing a case pretty soon, so that I can tell that I may not disclose the complete case study. We are writing a case in collaboration with Professor Dr. Deepak. So we have written a lot many cases, industry cases, academic cases, introductory level. Webinars are there. You go to jump.com webinars, okay, jump/webinar, for example. If you want to learn, lot of webinars are here. Okay, so the events, the recorded webinars, live webinars. Okay, so getting started with JUMP. Check out all the webinars available here. jump/webinars. So students have all the live webinars here, recorded webinars. If you look at academic webinars, we have special academic webinars. If you want to see, click here to register. Our academic webinar library is here. If you want to specifically look out for anything, see resource for teaching also, data summary analysis, predictive modeling, structural equation model, design of experiments, all this, including some of the authors being Doug Montgomery are part of this. Guest speakers, they do come for our webinars and we host this. Okay, so resources are on team. Go to YouTube, you will get this. A lot of videos are there, 1-page guides, 1-minute videos are all there. Okay, so the last but not the least, before I open it up for the question, there is a course called Statistical Thinking for Industrial Problem Solving. Irrespective of which stream you are working, and luckily you people are all part of business analytics course, most of the things you would have covered, whatever I told you. This is a course which is a 42 hours course, which is a free course online available both on Coursera and Jump. Simple. Yeah, the best thing to go is STIPS JMP. So this is a free online statistics course where it talks about statistical thinking of and problem solving, exploratory data analysis, quality methods, decision making with data, correlation regression, design of experiments, predictive modeling, and text mining. And you can complete it completely free. It's a totaling 30 hours course, self-paced learning. Professor Mia Stevens is part of this, Mia Stevens. So, and then you can flash it onto your LinkedIn website. You will have a kind of a cloud-based Jump software which you can use it, or else you can download a 30-day free trial also, you can complete it. But if you want a certificate from SAS, you might have to go ahead and then write a 3-hour examination where if you pass that, you will get a certification from SAS, which is very, very much appreciated in industry also. It's called a STIPS course. Okay, this is built keeping in mind the requirements of industry and as well as what we think will be very essential for researchers and MBA students, irrespective whether someone is a HR, finance, whatever it is. We feel that this is one important thing. Available both on Jump website and as well as on the Coursera website. So Coursera, if you do it, they might charge you a $20, but if you do it Jump website, it's completely free. I think for you, Coursera is also free, I believe, for your college. Yeah, most of the academic institutions this year, the Coursera was free. Leans, it will help us to lean software, lean Six Sigma, right? What is that question, Chetan? Lean software, what is that? Lean S/W software. Learn, okay, LER. So the spell mistake. This is the text analytics, okay. So you can use it to learn, you can use it to teach, you can use it to learn better and then apply in your projects as well. Yeah. Any other questions? 12. Any specific thing you want me to show? I can go on and go on. So Jump has all these capabilities. I was saying that you have to, what I know about Jump is last from 1 year, probably 1 or 2%. Okay, honestly speaking, it is a robust, easy to use software, not only for industry, but also for academic research and learning. And as I said, it's been used to teach some of the business research methods, research methodology, your business analytics, data science program, quality and reliability, Six Sigma, basic statistics, survival, design of experiment as a prescriptive analytics. I know a couple of colleges, premium colleges, they have incorporated DOE as part of their analytics course. It's very, very important. And there is a guide called DOE Introductory Guide JMP. That's something which I super like it. Design of experiments course. Okay, this is also an online course, design of experiments. So go ahead and then take it. Screening experiments, response surface, and I extensively used in my campaign analytics in marketing. Back, I'm talking about 2006, 7, not 6, 7, 4, 5, 6. Okay, where how do you optimize your so-called market mix optimization, MMO, or media mix optimization? Those are all design of experiments only. How do you find out whether women like thick crust pizza? I'll show an example. Okay, so there is a max diff model, potato chips, whereas consumer preferences, where is the association, market basket analysis you would have taught. Okay, where is my uplift model and choice modeling? This is called choice model or discriminant analysis, you call it as pizza combined, whether your men like thin crust pizza or not. Okay, you can see this from a utility standpoint. Looks like, what is the utility when it comes to thick crust, thin crust? the desirability or the utility comes down for thin crust. This is only for men. For women like thin crust pizza. So you can gender based, you can see this. I can show you another analysis here. Their choice modeling, who prefers what kind of analysis here. From a gender perspective, let me add a little more factor profiler here, utility profiler. You can see this. So which utility makes difference? So for example, for male, okay, so thick crust has a higher utility. If I come down to thin crust, they have a lower utility. So if I change this to female, looks like, see, female prefer thin crust compared to thick crust. So these are all visually you can understand, at the same time understand better also, and make you, this is called utility profiler. Again, you can optimize desirability. Interactive profilers are available. So see, we are all visual creatures. This is what I've been telling my son also. If you tell me a story, I might remember, but if you show me a picture like KGF, I remember for a long time. Okay. So visualization is very important, whether it's data or life. So I strongly believe visual teaching with a visual guide is very important. And especially from a data science and analytics perspective, these kind of visual tools helps you to understand the problem better and then visualize the solution better, and then conceptual clarity will be better, and at the same time you can understand the better context also. So any questions, sir? Is there any demerits in jump? Most companies ask for Python or for business analytics. Any reasons why they prefer it? Hey, as I speak, AstraZeneca uses jump. You know, we're all dependent on um, uh, COVID medicine, right? I always say this to my son. We respect all other softwares. Okay. Demerits, yeah, there could be demerits. This is a expensive software. You might have to pay for it. Okay. Anything which comes free has a cost. R or Python or any kind of open source softwares are freely available, but it has a cost. And then writing a right, you have to differentiate as a engineers or as a managers, as a decision makers. First thing is, it's important to ask the right line of question, then writing a right line of code in management, in leadership. You can go back and change your code and then rerun. I've been running a lot of programming also. So from a deployment standpoint, people use SAS also. SAS is a powerful. That's my company also. You might use SAS or Python deployment. By the way, jump is integratable with Python R. Okay, so you asked a very nice question. So if you're teaching along with jump, you can wrap on top of it RLS SAS Python. Okay, so if you look at this, there is, if you want to do jump integration with Python R, there is a beautiful paper written by um, Ruth Hamill. So she is my colleague. So jump is a standalone fully featured, but it is integratable. So you can use along with this. And then some of the companies, they do use jump, they use R, they use Python. So we are not saying that. So it doesn't mean that if you have a white shirt, you cannot have a cream shirt. From a different perspective, you can have a white shirt, you can have a cream shirt, you can also have a red color shirt also. So it depends on how much time you have. Okay. So why some people prefer Python? Okay, it's okay. That's why if I can tell Tata uses it, or NASA, I have a I know NASA, somebody from NASA came back, they gave a presentation using jump and they've been using it. It's not like that they don't know Python or R. They might be integrating at the same time. How much time it takes you to write a code, and then not everybody would like to code also in life. Okay, let me tell you this. If you're expecting a medical professionals to write a code, their time is more valuable, right? Again, technology should help us to perform faster. So if I can run a model, all the 6 models in 6 seconds or 6 minutes and give the result in a couple of minutes, time is money, money is time. I'll surrender my case there. They prefer it because it is visually enriching and it is a desktop-based event software. Even if I'm moving out of this organization, for example, you need not go through the code. You just see this and drag and drop. The best part is you can save the analysis inside the data table only. So if I save this, if I want to see how it has run, okay, where is my choice model? There's a choice model. You can see this. You click it here. You want to see what code it is, edit, you can see the code also. When you drag and drop automatically in the back end, a code script also gets. This is how they use it to automate also. Companies use it for automation. Yeah. You can write on top of it R or Python. You can wrap it and scrape it. Yeah. Suman, did I answer your question?
Yes, sir.
So it's really important. You never know what other organizations will be using it, right? Until unless you get inside it. Some people might use it R, some people might use it Python, some people might, it's just that Java, they should be happy with C, Perl, and they might have their own captive, they might use SAS, Jump. So we are not talking about program centric approach in problem solving. We are always talking about problem centric approach. And Jump is built keeping in mind problem centric, not program. You take out the pain of programming, you focus on the problem, explore. That's the reason. I use the word. We use the word discovery. Okay, how quickly you can discover insights. Thanks, Sumant. Thanks for that question. Any other questions? Anything you want me to show you? And just to give you, it is only a 700 MB software. Okay, as a computer science engineer, how can you build such a software within 700 MB, so powerful, so visually enriching? And then it can take millions of rows also. You can connect it to, I said, even you can connect it to databases, okay, servers, and internet scrape from the web page, Google Sheet. You can connect it to a SaaS and then run. This is a SaaS product. So you can open, you can automate, you can build a dashboard. There is something called Jump Live. So if you see this Jump software, it's something called Jump Live. I haven't even touched based on the Jump Clinical and Genomics, which is extensively used by regulatory authorities. Okay, clinical for drug discoveries, and then Jump Genomics to understand the genomic structure. And those are probably, if you have anybody in the group who is into hardcore biology or else in agriculture. So this is where the actual science things happen. Okay, actual science, and this is all data science. Okay, this is the actual science. This is the data science. Any other question? Okay, I'll enable my video so that you can see me, at least who those people who didn't see me in the beginning. Okay, so STIPs I told you, this is something which I strongly recommend. And there are a lot of course collection materials, case studies are available by be it statistics, data science, predictive modeling. And I said certifications are also available. Go ahead and then explore those things. So we are in conversation with universities and colleges where we propose unlimited license of this software. Okay, starting this year, we've been doing it where we want to give the software unlimited to a department where the students or the faculties, whether they're working from home or so studying from home or else in the laboratory, they can start using it. That's something which I had a discussion. So that's for the faculties who are part of this discussion, where we propose unlimited licenses with very nominal cost, including the workshops and complementary trainings and workshops. That's something which we have planned this year in India, while it has been there across the globe. Yeah, some of the colleges are already on this path. So Jump is not a software to learn. Okay, Jump enables you to learn the concept. So you don't need a learning curve to drag and drop in Jump. So we never say, that's why we say, even the core certification, we say Jump certification. We never say, we say STIP certification. So if you look at the technology is an enabler. You might use any other technology to solve your problem. Jump is one of them, and which help you to quickly solve problems. Just to summarize, here is my final slide for the day. Statistical thinking is a need, essential skill. It is no more a specialized skill, whether you do LLB or you do odds or you do anything in your life, sports or anywhere. So statistical thinking is no more a specialized skill, it's an essential skill. And thank God all of you are learning those things and you've learned already. And statistical data analysis techniques, reliable and valid results and quicker results. It's very important that you focus on. There are multiple techniques, ensure that the reliability of those and validity, and then ensure that when you're giving data or the information has an expiry date. Keep that in mind. Learn to teach to learn and learn to teach, especially for professors and research scholars. We are here, Jump Academic program is here and Jump Academic team is here to help you out. So Jump is a powerful and easy to use tool for data analysis. So that's been my final say. Go ahead and explore Jump trial version, and then you can also explore steps. And if you have a LinkedIn account, please do connect with me. This is my LinkedIn account. So at least we'll be connected, especially the students. You never know. Some of you might, you might meet in future. So this is, you can search for Muralidhara Anandamurthy. So you'll get, so just to keep in touch, I can give you a little more information on the Jump or else on the regular predictive modeling or AI or as the design of experiments or any kind of free resources available. You can always follow on this. Okay. Sir, any other questions at this point of time?
If others, okay.
I'll stop sharing.
Students, do you have any other questions?
So I would like to hear your feedback.
Definitely, I'll be. This was a fantastic session, and I was, what I wanted is, Murali, that if the students are able to appreciate the software also right in the beginning, so whatever the tougher route that they have taken so far in understanding these concepts, they will be able to appreciate now that it is much more simpler. So even drag and drop method is much more effective. But what they should be able to know is they should be able to understand the concepts in the beginning. So once they have understood the concepts, and if they know what these concepts are, when and where, what to use, then based upon the data, Jump would make everything very, very easier.
Yeah, agree with you, Professor. Totally agree with you. It's very important that we call it as conceptual clarity and contextual familiarity. Those are the two words we always say that, you know. So if you're learning statistics, learn understanding the foundations of it, and statistical foundations are very important. And then tools are enablers. And then you might pick up a lot many tools. Depends on which organization you work, and they might be using simple Excel also for that matter. So it should not make a difference whether you have picked up this tool or that tool. You can always pick up tools overnight also. It's not a problem. So understanding the fundamental concepts is very important. I totally agree with you, Professor.
So any more questions, guys?
Sir, I have a question here. Sir, the JMP plugin in Excel, what applications we can perform, sir, using the JMP plugin in Excel?
I think what it opens is, it opens some of the into data sets, and then it automatically runs through. You need to have a Jump. First thing is you cannot, it's an add-in once you have a Jump Excel plugin. So it's not like that you can only download Jump plugin for Excel. So you need to download, install Jump, and then it will show a plugin where that you can open some of your data from Excel only, and then you click that, automatically it runs in the Jump. So those are the capabilities. It's just that somebody is used to Excel, and they can launch Jump from Excel only. So the data analysis fit by model, you select this and then run, automatically it runs in the Jump. That's how it is built.
Sir, can we perform all the operations that you showed now in the trial version?
It says fully functional, yes. 70 to 80%. If you're looking at generalized regression, no. If you're looking at model comparison, no. You cannot do that. That is the Jump Pro version which I showed you. But for that, you might have to have a license. Okay, so that's the fully functional. What I said is fully functional of Jump is available. What I showed you is Jump Pro, which is little more advanced version, including structural equation model or partial least square or functional data explorers. But 80 to 90% of whatever I showed you you can do it using the free trial version of JMP. Yeah.
Thank you, sir.
Welcome.
Okay. If there are no more questions, only thing is probably we need another session on design of experiments, Murali. Probably time was not there.
No, I thought of connecting on the DOE. I looked at the time. DOE takes, especially for marketing, and then DOE for finance, or DOE for operations, or DOE for services in hospitality industry, how they use design of experiments in marketing analytics. So that could be another area where we can definitely connect.
Yeah, no problem. So if students don't have any questions, then it's my honor and privilege, Murali, to thank you for being part of this session. And so on behalf of the Institute, faculty members, students, I take this opportunity to thank our today's keynote speaker, Mr. Muralidhara, who has been kind enough to accept our invitation and spend his valuable time today. I thank our principal, Dr. CBS Prakash also, and our head of the department, Dr. KG Hemlata, for her constant support and encouragement. So thank you all faculty members and students also to be part of this event. And I request you all to attend our upcoming sessions also during the 10 days AI conclave. Thank you very much.
Thank you so much for the opportunity. Have a great rest of the day, all of you.
Yeah,
Take care. Bye.
Bye.
Thank you, sir.